Good morning, all, and welcome to our first panel of the 2021 Connected Aviation Intelligence Summit. My name is Woodrow Bellamy III. I'm the Editor-in-Chief of Avionics International. Before we do start today's panel, I do want to thank our sponsors, Intelsat, SES, and Comtech Zycom. Without them, we would not be able to put on these panels this week. Also do want to let our audience know, as many of you know, we have been hosting the Global Connected Aircraft Summit since 2014 as a live in-person event. Last year and this year, we had to postpone the event due to COVID restrictions. We do plan to bring that back live next year, the first week of June at the Hyatt Regency in Reston, not far from the Washington Dulles Airport here in the Washington, D.C. region. So we will return as a live event next year. For this event this week, we do have a couple of different panel discussions, and we're really excited about them. We have some new speakers and new topics. For this day, we will have this panel on 5G starting at 9 a.m. Following this, we do have a panel on the cost of making in-flight connectivity free at 10:30. And our final panel of the day will start at 1 p.m., focusing on IFC trends. Now, let's get into our first panel of the day, looking at the potential benefits that 5G could bring to aviation, with a focus on our favorite topic, in-flight connectivity. We have a very well-rounded panel of experts, including David Fox. He is the Vice President of In-Flight Connectivity and Services for Deutsche Telekom. Amar Khan is the Chief Operating Officer of Sky5 AG. Aditya Chatterjee is the Senior Vice President of Aero Segment Market Solutions for SES, and Jim McDougall is the Vice President of Product Management for GoGo Business Aviation. Thank you all for joining me this morning. So I want to start out the panel by first starting with Mr. Fox of Deutsche Telekom. Now, obviously, it's a very exciting topic to not only aviation, but many different enterprise industries on the ground. A lot of service providers are starting to roll out 5G services. And I think like every other technology that aviation has adopted, this will probably be the last industry to adopt that technology. So now is a good time to start talking about it. So David, Deutsche Telekom is well known for supporting the integrated satellite air-to-ground network, the European Aviation Network. Can you first just start by giving us some perspective on the types of in-flight applications and passenger usage that the 4G European Aviation Network is enabling today, and ultimately give the audience an introductory understanding of what 5G is, what it means not only to Europe, but overall in-flight connectivity as a next-generation technology?
Sure. Well, thanks, Woodrow, for the question, for the introduction. Well, the European Aviation Network provides a true broadband experience in the sky for passengers in Europe. So I could talk about low latency and high throughput all day, but I think the easiest illustration would be the recent piece on ITV in Britain, where a journalist streamed their segment from the aircraft, real-time HD, and it works in both directions. So I just had a real-time WebEx conference with the video on with one of our engineers on an EAN aircraft of one of our potential next customers. So the experience is just like on the ground. I think that's the key word here, and the statistics back it up. So if you just look at the consumption, the most popular use cases of our customers are Netflix, YouTube, social media exchange, just what you would expect in user behavior from someone who's given a functioning, working broadband connectivity. Looking at the 5G now, and moving away from the Europe and moving on from the European Aviation Network. As you already introduced, Deutsche Telekom, we're a leading European 5G operator, and let's not forget our friends here in the US, T-Mobile US. We contributed significantly to the development of 5G. as early as the first NGMN white papers, as well as the 3GPP standardization. On the ground, we have Germany's largest fiber network and as well as the largest coverage of 5G already today. You mentioned the rollout on the ground is going on, and we're doing that with speed as well. So in Germany alone, we're upgrading or installing up to 2,000 new sites ready for 5G every year. And we consider 5G really as the natural evolution of LTE or LTE advanced. If you look at it in the context of in-flight, delivering, you mentioned it, the European Aviation Network, delivering the ground component of that hybrid network, that will stay the best in class for many years. 5G will complement and enhance the solution and eventually will allow for even more bandwidth and even better coverage. What I would expect with 5G for aviation, I would expect further economies of scale. So if you look at what's happening in China, in the Middle East, this starts to make it interesting for suppliers to develop integrated units. And then you're suddenly looking at solutions that could make a case for international air-to-ground solutions, in particular, if you look at routes crossing land masses, Europe to Asia, the US is a no-brainer. I'm sure Jim will already pick up on that after me. So I could see other telco operators as well entering the market, providing regional air-to-ground solutions. And being from a telco myself, I would envision roaming to hold this together as kind of the glue. So imagine if just you, Woodrow, are taking your smartphone across the US border to Canada, you expect the connectivity to still be there. And I would see 5G roaming with other operators to be just like that.
I see. And so, Amar, now switching to Sky5 now, you've had a couple of different announcements in recent months, and I came across Sky5 particularly about the Airbus announcement that you all had back in, I believe it was August. But as one of our newest speakers, and even though there has been a number of major announcements around your company's development of 5G air-to-ground connectivity for the Chinese market, it'd be good to start with a baseline understanding of who Sky5 is, and what's your current status of the development of a 5G air-to-ground network for the Chinese market?
Thank you. Good morning, good afternoon. Thank you very much for the introduction. Firstly, just let me lay out the basics. So Sky5, we're based in Munich. Although we are 2 years into our journey, the people that are working have been involved in in-flight connectivity for over 10 years, including with David. And we build together with DT and our partners in Europe, the European Aviation Network. So we come with that heritage. And now it was a management buyout from Nokia 2 years ago with the air-to-ground business. And our expertise and specialities lie in delivering in-flight connectivity for air-to-ground. So that's just the basics of who we are. Our focus areas are threefold. As David said, picking up from that point, the technology cycles in terrestrial networks would be longer for the in-flight connectivity piece, and the Europe example of the 4G is very well positioned and good fit for purpose and would continue. So one of our efforts is effectively offering a similar network in the rest of the world, because it's there, it's mature, it works, it has demonstrated that it actually can perform with a home broadband like solution for people flying in the aircraft. So that's one focus that we do. The second focus and the biggest advantage, one of the biggest advantages of air-to-ground, is the small form factor that comes with it. So we can effectively target markets like emergency networks. So one of our initiatives is in New Zealand. It's public information. We are working with effectively the police and the rescue teams in New Zealand deploying air-to-ground compact solution in helicopters and turboprops and those kind of form factors to actually provide high quality of service, which they're not able to get. So that's the other dimension of the advantage of an air-to-ground type solution. And the third element is at the moment focused on China. It's only focused in China for two reasons. Firstly, they have chosen to skip 4G completely. From a connectivity perspective for the aircraft. They have already allocated spectrum for that purpose. And therefore, there's a huge drive in China to make a solution happen, which is why we partnered with Airbus to effectively develop a local solution in China, because a large market is unconnected in China because it's a very difficult market to address. But having said that, that solution is not bespoke just for China. The solution can be tailored in other places, but it's all about timing. As David mentioned, normally the advantage of using a terrestrial network is you gain from all of the services that have been launched to me and you and customers that are using 4G. It all matures through a timeline, and then you adopt it for these special cases. And 5G would be no different. 5G is in infancy phase. It's being launched at this point of time. It's going to improve as it goes along from all the trials and all of the experiences on the ground. And then eventually, depending on timing, depending on spectrum, depending on region, it can actually scale. And the last point is, regardless of it's 4G and 5G, or as long as the baseline uses a standards approach, you have interoperability, mobility, and roaming that comes with these islands. So what we are trying to do is, depending on the region, go with a domestic regional solution that addresses regional market, and effectively try to bring all of that together to provide a holistic customer experience across different regions.
See, thanks, Amar. And now moving to Mr. Chatterjee, you're actually the only representative of the satellite market on this panel. So obviously you come to this with a very unique perspective. Considering that 5G is a next generation cellular radio technology, could you just start by giving us an update on some of the latest next generation satellite IFC related technologies that SES is currently working on? And how do you see that coexisting or being compatible with the capabilities 5G could bring to in-flight connectivity?
That's exactly right? The coexistence of a satellite network with a terrestrial or an air-to-ground network. SES is a global company, right? I mean, we have global coverage, and we are what they call multi-band, multi-orbit, right? We have KU, KA, C-band. We have geo satellites, non-geo satellites. So very early in the aviation service strategic planning, the idea of SES has been that we are a global network which provides global coverage. So that's one thing which makes a satellite company, a bigger satellite company like we are, a little different, right? But the second thing, which is obvious, is that you cannot run a passenger experience to a very optimum level based on one technology. So end-to-end seamless connectivity to a passenger from home to home, from an airport to an airport, is tantamount to SES as somebody who will bring such a connectivity, but not alone, but with partners, with telco partners. So telcos are traditionally a big customer of satellite companies for places where they can't put in lines, right? So we do want to work, and we have had discussions with telco providers, that can we build together a seamless network which will provide such an experience to the passenger, who will consider that he's always or she's always connected from home to home, or home to office, or office to home, while he or she is traveling. So part of our development not only has to do with the next generation satellites, but to make sure that the architecture of that any network we create is kind of compatible with the ground architecture, right? We are one of the first, and I think till now, the only satellite network provider who has gone ahead and got certification from the Metro Ethernet Forum. So, by definition, we accept that there is this enormous ground network, now 4G going to 5G, and there is a lot of 5G in progress, which needs to be accepted and integrated for an overall solution with us. Now, what that does to the next generation of satellite building is that it enables you to concentrate on very specific technologies. It's not, we have huge satellites, it will provide a whole bunch of coverage to lots of places on the world, and everything will be ubiquitous, right? You use satellites tactically and strategically, and for that you have you have software defined satellites nowadays, right? You're creating those. Airbus is creating them, Thales is creating them, Boeing would be creating them if they haven't already. Actually they do. So we have what we call the concept of dynamic beam mapping, hopping. You can follow an aircraft now, right, with a beam from a satellite, or you can follow a ship, right? And you have this dynamic capacity allocation. So you have the entire dynamic software configuration part of how you can control an intelligent network is now being built in a satellite network. You combine that with the extreme, advanced architecture of the telco networks, which all of you are creating, and now you have a seamless connectivity to the passenger. So that's the vision SES has always been going into. We are now implementing the vision. As I said, we are the first and till now the only certificate of the Metro Ethernet Forum, and that includes latency and all those tests, of course, because of the NGSO part of it. We are a very big cloud interface partner, and most of our focus to work with airlines or with partners such as David and other IFC and other telco providers and aviation service providers. So I hope I'm giving you an idea of how integrated satellite is becoming by definition, by design, by architecture to provide a global network. Because I believe that without a satellite, you can't have a global network. Okay, and it is ubiquitous. And there is a lot of use for satellites. I mean, IFC uses satellite big time right now, and it will continue to, but as a combined network.
Okay. And moving on with our kind of introduction to this topic, this is good to get an understanding from each company. So Jim, GoGo Business Aviation first unveiled its plans for a 5G IFC network in North America in 2019. He first should start giving us a baseline understanding of exactly how that 5G network will work in terms of the spectrum it will use, and ultimately how GoGo will enable this new network from a service provider perspective.
Yeah, thank you. Good morning and good afternoon, everyone. GoGo is in the midst of rolling out a entirely new network for 5G, which will be using 60 megahertz of unlicensed spectrum. And we will be pairing that with the 4 megahertz of licensed spectrum that we have today. This network will be, so in effect, 2 networks on top of each other, will be solely dedicated for aviation. And so we've architected it with mobility in mind. The network, 5G network, will be truly 5G end-to-end. The airborne equipment will have a 5G chipset. The ground-based radios at each base station are 5G, and our data center servers are all 5G core servers. So it's truly a 5G experience. In terms of the technology, each antenna is using beamforming to provide an improved experience, and By using both the licensed and the unlicensed spectrum together, we ensure that the customers will get the best possible experience even when they're in congested airspace over heavily populated areas. In terms of the service provider aspect of this, GoGo doesn't use a VAR structure today, so all of the service similar to today, all of the service for 5G would be sold and offerable directly from GoGo.
And I do see a couple audience questions coming in. Please do go ahead and submit those throughout the discussion. We'll try to get to as many of them as we can after we get through the sort of moderated questions, but I do want to open this up as much as possible to audience questions. So moving on, and I want to start with Jim in the second round of questioning. I want to focus on the aircraft equipment in terms of antennas, modems, and onboard technology. Starting with Jim and GoGo Business Aviation, what actually has to change on board the actual aircraft to enable the use of 5G?
Yeah, we can all of us put together a fantastic terminal, an offering, a service package. But if it's hard to get it installed on an aircraft, or if it's it's painful for a customer, then the adoption rate will be quite low. So this the experience of installing the equipment and activating the equipment is very high on our list of things that we need to be very thoughtful about and ensure that we do this in an easy manner, as easy as possible for customers. So when we developed 5G, that was one of the top priorities, is how do we make this as simple and easy to upgrade from an advanced L5, which is one of our today's 4G experience boxes, and it is the path to 5G with GoGo. So starting with an L5, the customers would have to add an additional LRU. It's 3 MCU. We call it X3, and that basically contains the 5G modem in it. There's 4 interconnect cables that would connect between the X3 and the L5. And then we have 2 existing antennas on the aircraft. You'd have to replace those with the new 5G antennas. We took the opportunity as we were developing the new antennas to also integrate our terrestrial modem antenna. So customers would have the option of removing that from the cabin and utilizing the terrestrial modem inside the exterior 5G antennas, which will also give us better performance on the terrestrial modem side. We really thought about this far in advance as we began to design and build the onboard equipment, so that installation would be efficient and save time and money. In terms of where we're at with all of this, we kicked off this program a little short while ago, about a year ago, and the aspects here, we have the network side as well as the aircraft terminal side. So we're going to begin construction on the network here in Q4, and we'll have 10 sites up and running by the end of the year to serve as our test network. And then continuing to build out that network throughout the first half of 22, so that we can launch in the second half of 22. And it will be a full nationwide network, coast to coast. We'll be starting with the United States when we go live, and then expand into Canada and Alaska and the northern edge of Mexico, so that the footprint will be very similar to what we have today. Development on the network, the backhaul, data center, all of that onboard equipment is underway. And we've actually passed a couple key milestones here in the last couple months on our path to 5G. Just last week, we hung our first 5G antenna on a tower. And so we're beginning to do testing on that. We've done some initial flight testing to collect performance data. We've done our first end-to-end data session with a GoGo SIM card, which was really exciting. And then in terms of development of the LRUs, the antenna has passed CDR. We have prototypes available now, and we'll be going into qual at the end of, or in Q4. That X3 LRU will have prototypes this month and going into pre-qual in August. Base stations completed PDR in 2020. And as I mentioned, the first antenna was just installed. And then the data center the 5G hardware was installed and became operational actually in December of 2020. And we're currently doing interoperability testing with our partners, Cisco and Airspan. So really exciting on the network deployment side, the aircraft side, moving right along to get this to the market next year.
All right. Yeah, certainly a lot of good updates there from GoGo. And so moving right along, Aditya, from a satellite perspective, you want to ensure that the actual aircraft equipment is compatible with SES satellites today. How are you going to ensure that that equipment is interoperable and compatible with 5G networks?
Well, first you have to worry about whether they're compatible with the next generation satellites, right? So there are two parts to that question, really, right? There are satellite antennas, which always would be satellite antennas. And then there are 5G antennas, which would be 5G antennas. Now, I mean, I think David and Amar both talked about integrated hardware, right? Which could work with, which has the capability then to join both networks, not necessarily through the same LRU, but with a capability to join networks on the ground as well as on the air through satellites. What SES first focuses on is efficiency over satellites. What hardware can we sponsor or co-develop together with the big product players or even new product players coming up in who are creating these kind of terminals and modems? So we work with a lot of these new players and existing players to ensure that the product or the terminal they are creating is compatible with the current version of our satellites and compatible with the next generation satellites. As an example, a typical example would be creating terminals and ensuring that this would not only works for geosynchronous satellites, for non-geosynchronous satellites as well. So we do have the world's first non-geosynchronous, geosynchronous operational network, the O3B network, the KA network. And we have done a lot of tests with current terminals to find out whether they are compatible with NGSO satellites. And most of them are, right? So that's one part of what we do. And then we work with the same product providers to show them our next generation technology of satellites and really ensuring that what they are building now would be compatible with the future satellites we are going to operate, right? So there is a process which we use, and it is a long-standing process where we work with product providers to enable them to certify their products on our current networks and make them test with the future satellites before they become commercially available. So that's one part of what we do. On the in-cabin equipment, we ensure, and it has been for a while now, where you put a satellite modem and then you put a 3G SIM card or a 4G SIM card and now a 5G, right? It has been a long while that technology exists where the servers inside the cabin, the LRUs, host two kinds of access equipment. So now what we are seeing is that the product provider, and this is through our sponsorship, the satellite VSAT or the modem provider is using architecture, a backbone, which is a 3GPP backbone, right? So in other words, the satellite software or the data backbone is actually similar to the 5G on the ground telco backbone. So what that does is that puts the entire network on a ground where you could actually, right, be extremely architecturally compliant, right? So that's the way I think satellite providers such as us who believe in this integrated alliance model, what I would say, are ensuring that the products use or they recommend or they provide to their IFC customers would indeed be compliant with the 5G architecture of the ground. Does that answer the question?
For sure it does. And so moving right along to Amar. Now, same question to you. Considering once again kind of the regional perspective that Sky5 brings, although you know, as you mentioned, this will be a global solution. What type of aircraft equipment will be required to enable the use of Sky5 5G in the future?
Thank you. So there's one comment I'll make before describing the onboard equipment. There are different ways to cut the slice between what the network supports and what the aircraft equipment supports. So I want to lay out as a first principle, we are close to a 3GPP implementation. That's what we try to do. All of the ground network needs to be vendor neutral, needs to be a 5G NR based solution. For a 5G case and a 4G case, it needs to be LTE based. And that effectively gives us a choice whereby all of the changes that have to be done in order to basically make it work in an aviation environment are not done on the network side. So the focus is coming up with a device that effectively manages the complexity of the aviation environment. So putting now that aside, the biggest advantage of air to ground effectively is the physics that helps. You're closer, the aircraft is closer to the base stations. And effectively what you can do with that is really create small form factor onboard solutions. It is not unheard of, and in Europe there's an example which David could illustrate. It's much less than a 10 kilogram solution, whereby you can actually really quickly install an equipment, which is one of the key criteria that Jim mentioned. It needs to be less painful. It needs to be easier to install. And we don't see it any different. We have started that work with Airbus. We have actually demonstrated some of that capability in China towards the end of last year. We continue to develop to make sure that it is a simple solution which can be installed in quick time and effectively supports 5G to start with. But then coming back to Aditya's point, the advantage of actually this approach is to make sure you can then host other bands as well as 4G, because you expect 5G, 4G to work in your phone, right? If there's no 5G coverage, it should work with 4G. And that would be the natural evolution. And then comes the SES view at some point of time, which is not in the far future, actually. You will start looking at a view where the experience is effectively available throughout at a global scale, where effectively developing solutions that integrate satellite in some form or shape, even though if it's not at a single LIU level, it can effectively be at a multiple LIU level, absolutely. But from a customer perspective, if you're over the ocean, you have the similar experience if you are actually surrounded close to an airport where there's a lot of demand. So that would happen eventually. And that's roughly what we're doing.
And moving on to David and Deutsche Telekom, you know, you come to this obviously from another unique perspective, because not only do you support the actual, you know, in-flight connectivity, but passenger devices, the mobile devices as well. You're going to have 5G phones. What is the actual aircraft equipment that can enable the use of 5G in-flight in Europe?
Okay. Glad you're introducing the device perspective, because I think it brings along a good analogy of what we're trying to, you know, what I could foresee happening with the migration or an addition of 5G. Because what happens today is if you have a 5G enabled device and you're surfing in an enabled cell, then that's what you're getting, a 5G connection. But if you're coming with last year's iPhone, which only has 4G, you'll still get very good connectivity from the same cell. You probably wouldn't even know the difference, but this is something that is already working today. And this is something I would envision the plan for let's say a 5G you know, transition as well, where I don't think 5G doesn't mean or means the end for 4G, but it's an evolutionary step. So if you make a decision for a 4G solution today, you don't need to be afraid of obsolescence. For the passenger bringing their device, quite frankly, I think Wi-Fi is here to stay. And we will be seeing passenger connectivity via Wi-Fi and probably say more traditional connectivity methods for some time to come. So I think for the passenger, it shouldn't really make a difference. I think that's quite an easy approach for us. If we then look at it from the network perspective, very similar to the statements that we've heard from the other participants. I mean, we're hardware ready for 5G. So many elements are ready when the time comes to be upgraded. I don't think that the equipment in its form factor, Amar already alluded to this, will look all that much different from what we're currently using, which is already very ultra lightweight and really easy to install. So it could even be light enough to say, well, look, we're adding this as a complementary connectivity, and that just gives you an additional connectivity to the aircraft. So from our perspective, the transition should be smooth and easy. But especially in the context of Europe, I think it'll be some time until that actually happens.
And so I'm actually going to open it up to the audience questions now, because we do have quite a few that have come in. As you can see, a lot of interest in this topic. So let's start with the questions that are addressed specifically here to GoGo Business Aviation. The first one, Jim, is an investor question and says, do you have an update on delivery of the chips needed to launch the GoGo 5G network?
Yeah, great question. The GoGo, just like everyone, has been impacted by COVID and the impacts on supply chain. So the dates I gave you earlier regarding a qual on X3 starting at the end of this year, going into early next year, and then hardware availability and network launch in the second half of next year is all taking into account any chip delays. We did see some hiccups in the supply chain side, but we were able to overcome them and shuffle some activities around on the development program to maintain our launch date that we had initially advertised.
Next question is for you as well, Jim. And this is a particularly interesting one. Do you envision that things will move to open RAN and open standard rather than vendor lockup, especially around monitoring systems? So it seems like they're asking about sort of the aligned technologies on board an aircraft that you can kind of open up new applications for with 5G.
So in terms of the GoGo systems and how we monitor the experience, how we monitor the connection that the aircraft would have with the network, that's all GoGo tools and services that we have today, and we would continue to offer with 5G. We do work with third-party partners on things like routers, right? So that if a customer has a particular router that they wish to use, they don't want to use the GoGo router, they have another one they want to use. We work with those companies to ensure that their router technology works with our hardware, so that that router provider could provide some value-added services on top of the GoGo system to offer to that customer. So things like monitoring your connection. In terms of working with other things on the aircraft, we do envision that. We've had conversations in the past with different avionics companies on how to integrate and utilize the pipe that we provide to and from the aircraft to offload things like engine data or avionics, fault messaging or weather data, and so that would certainly continue as we roll out into 5G.
And the next question was sort of open. It's actually a question that I had myself. I think I'll maybe start with David, and if anybody else does have comments on this, please do chime in. But I'll address this to David first. What will 5G bring on top of 4G in an aircraft? So it's just kind of a general question. You know, what type of new passenger experience will 5G enable?
Okay, so in its very essence, 5G to the aircraft will be a complementary link to the aircraft that, say, complements, in the case of Europe, the existing satellite and a ground component links via 4G to the aircraft. So this could give you more redundancy, potentially higher speeds and lower latencies. So we're seeing that there is demand for these high bandwidths in the user profiles, in what kind of content they consume, and this could provide potentially additional bandwidth. If you just compare like for like on the 4G versus 5G, just moving from 4G to 5G doesn't really bring you an immediate benefit unless you add a lot of spectrum to it, because the low latency and the bandwidth in a given spectrum, that's there the performance between 4 and 5G isn't all that much different.
And any other?
Yeah, I just want to add quickly to it. So it's a very good point. The difference between 5G and 4G for connectivity for aircraft is two. One is David mentioned spectrum. So the only reason why you would move is you would have sufficient chunk of spectrum. Like, for example, in China, if you had 100 megahertz of spectrum, you could do a lot with it, right? That's one fundamental piece. The other one is also, unfortunately or fortunately, linked to the spectrum. The 5G NR air interface brings a really, really good capability around beamforming, which is basically standardized. And that beamforming piece with the spectrum combined, basically in a similar cell or a site, gives the capability to actually track aircrafts. Coming back to to Aditya's point, you could actually, with those, start looking at providing that spectrum and the bandwidth targeted to aircrafts. But it comes back to the spectrum. If the spectrum is not there, there's no performance difference to move from 4G to 5G.
And our next. Oh, go ahead.
Yeah, sorry, Woodrow. I'll just add to that. I mean, I agree with what David and Amar are saying. That absolutely. The only thing I would add is that, you know, when you do go to 5G and using unlicensed spectrum, you know, it will be important to have that additional network behind it. Is the spectrum's great, the capability is great, you know, beamforming is great, but the problem is there's a whole lot of people using that unlicensed spectrum, and you get a lot of noise. Right. And so having the 4G,
I envy you for your geographical benefits. So I couldn't do unlicensed in Europe in built-up areas, but in the US, fantastic. I mean, we would have done it already.
Yeah, yeah. There's the pros and cons, you know, and so the 4G provides you that backup to help deal with the noise, so that you ensure the customer experience stays the same no matter where they're flying.
And so, Aditya, actually, the next two questions are probably well addressed to you, both satellite questions. The first one is, how cost effective do you think 5G backhaul for remote location using satellite LEO will be? So kind of an interesting question there.
Well, if I could understand the question.
I can probably take it, because we've had those kinds of discussions.
Yeah, please.
Sure. Yeah. You want to take that one?
Okay, because there's always been. I'm interested that the question was not, "Are you afraid of LEO?" Because there's so much bandwidth around. That's typically what we get asked. Are you obsolete because LEO is around? No, we're not. But we had interesting discussions with LEO operators, not just on the in-flight side, but with Deutsche Telekom as a whole. And what we see is they're not trying to compete with the telcos, but to complement. So now this also addresses a little bit another question there. What do you do in remote areas or over water? One of the biggest issues of building an individual ground station is to bring backhaul to that station. Now, I can bring energy via solar for a remote area. That's not a problem, but sometimes it's just not feasible to build something via fiber. So as an additional resource, one could think about delivering that backhaul via a LEO connection. As to the cost effectivity, I can't comment, but I could see a valid use case there.
And I mean, just to add to that, we do provide a lot of satellite backhauls exactly for that same reason to telco providers, right? Because some places you can't put a fiber. So a good chunk of capacity through a dedicated satellite backhaul could be ideal in cases like that. Now, in terms of cost effectivity of LEO versus 5G, as you can see, I'm really not the expert there, so I can't answer that question.
Okay.
Yeah, but overall, I think the overall story is that the technologies complement each other well. So if you look at the EAN network, this is a collaboration between Inmarsat's S-band satellite and the ground network of Telecom. So this wouldn't be the same without the satellite. And there's always integrations. We could see, I did hear what you've been talking about, integrating different technologies, telco on the ground and satellite, because let's face it, we can, let's say, as an air-to-ground network or a ground component, we can deliver this, let's say, in over the ocean with reason. If you, I don't know, hit an oil platform or similar. But for global connectivity, there'll always be satellite. I give up. I'm beat. But over land masses, I think we have got the upper hand, and then both technologies should complement one another.
Okay, and this next question actually was specifically to Aditya. It says, how will SES networks, and this is not really 5G related, but how will SES networks address polar region coverage?
Yeah, that's one of the global satellite operators' responsibility, especially if you go to such a IFC service provisioning, right? The problem, of course, on the polar region is from the perspective of business, there is not that much capacity required. So when you decide on how to provide, you don't have the owner economics to build satellites for what I would say less than a percentage of IFC coverage around the globe, right? So, however, a global connectivity is mandatory. And in order to do that, we are contemplating of two different ways, right? One is purely an SES way, where we have the Empower constellation coming up in the next couple of years. So we are doing a lot of analysis, design, and business thinking in how to add higher latitude coverages to that Empower constellation coverage, which is plus minus 50 degrees in latitude. And the way we are homing on to that is that we think we need more satellites, which is kind of an inclined plane satellite operations, which goes like this rather than like this. And you can have a coverage all the way to plus minus 90 degrees. So that's one way. The second way, which SES very much believes, is again working with satellite alliance. In other words, work with regional providers, other providers who do provide polar coverage, and create a roaming network, if you will, to augment your own global network, right? Because capacity is always required. Additional capacity is always required. So you have the option to build your own and then share that with others, or you want you have that option to ally or create an alliance with other players who do provide or who intend to provide polar coverages, maybe even through LEO. So one of the very important considerations when you create those is to ensure that you have the technology on the aircraft, and by which I mean commercial aircraft for the time being, right? Which would be compliant to all kinds of satellite technologies. Of course, there would be compliance with the ground technologies like the 5G and the 4G, right? But an antenna, as an example, you can't put multiple antennas on an aircraft, regardless of how wide-bodied or how big that is. Okay, that just doesn't make sense. So building the right technology, the right terminals, perhaps electronic steered array, is a very big consideration of what we focus on to ensure that that antenna would work for all kinds of satellites. And you can pick a band, whether it's a KU or a KA. Empower happens to be KA, right? But you have an equivalent OneWeb, who does plan to provide fuller coverage on KU, and we have geo KUs. So it's probably going to be through alliance unless we go and actually invest in the incline, which we very well could at a given point of time when the business grows up.
So we do have quite a few more audience questions listed here. I think I'm going to skip some of the ones that we've already addressed, the one about coverage over the oceans. Here's another satellite-related question that I'll throw up into the panel. Would a 5G transceiver repeater need to be installed on board in order and connected to a satellite network? Seems like they're asking in order to make these two networks compatible. Would a 5G transceiver repeater need to be installed on board to be connected to the satellite network? Aditya, if you want to start with that one, and anyone else chime in.
I will just start it, but I certainly am not capable of answering it in entirety. I think in the very onset of today, David did mention that there is the concept of hybrid connectivity on even a commercial aircraft. In other words, you have the satellite connectivity, the traditional satellite connectivity, maybe an advanced satellite connectivity, but because of the fact of the form factor being low and so on and so forth, you could conceive on a relatively bigger aircraft, given enough cost justification or price justification, that you could add a ground network or an ATG network or a 5G network out there, right? And that's where the transceiver comes in, an additional transceiver on a big aircraft already equipped with satellite. But as far as the costing of that goes, I am not capable of providing that.
Okay. So this next, I'm going to skip the other question. There's another LEO-related question. We already kind of discussed that. Here's another question for GoGo. This is a very interesting one. What speeds will GoGo provide once 5G is implemented?
Yeah, I get this one a lot. Unfortunately, we can't give out specifics just yet. We're still in the testing phase for the network and the hardware, and so we won't know for certain until we finish that up. But what we have said is that we expect 5G to be 3 to 5 times better than what you can experience today with 4G. And when we talk about that, it's important to note that we're not talking about maximums here. That when GoGo mentions speeds, it's the average experience to the customer. So maximums will be significantly higher with 5G compared to 4G, but the average we expect to be 3 to 5. Also to note, an advantage with air to ground, and I think David mentioned this earlier, is the bidirectional nature of this. So, when we talk speeds, it's going to and from the aircraft, right? Transmit and receive.
And another question for Jim: how many hours will it take to upgrade an aircraft? Presumably, they mean with 5G, but how many hours to upgrade an aircraft?
Yeah, great question. And also a big one when thinking about how to design the terminal and the upgrades is how do you make it time efficient for the dealer, your channel dealer that's doing the install work, the MRO, and your customer. And so we tried to minimize this as much as possible. I don't have an exact, X hours to do this, but we kept the cables the same. So in terms of cables between the LRU and the antenna, So you don't have to rip open the interior to do a 5G upgrade. There's no new penetrations, so that saves a whole lot of time. When you pull the antenna off, there's a thin adapter plate. We kept the whole pattern very, very similar to what's existing today. So small adapter plate, bolt the new antenna on. You need a 3 MCU space on the rack to fit the X3, and then you have the 4 jumper cables. And so that's it. It's a relatively modest upgrade to get from GoGo 4G to 5G. What will probably drive the time is that most customers tend to install air to ground or we expect 5G upgrades will often be done with other work. And so the 5G piece of this we expect to be very modest in terms of installation time, but there may be other things that customers doing while they're there.
And the next question, maybe I'll throw this one to Amar or David if you'd like to chime in. It says, what is the status for the plan of a study for potential impact on aircraft systems due to 5G radio wave interference? Any thoughts on that?
Okay, so I think I'm looking at a few questions. Right. So maybe I start. For any system to be on board the aircraft, whether it's 4G, 5G, it needs to be certified to be compatible with anything that is flying in the space. This was no different for the air-to-ground system at EN in Europe. You have to have a comprehensive testing around EMC, around environmental and everything to make sure that it does work across. Now with 5G, it kind of depends which band you're talking about. So it's hard to pinpoint which particular frequency we are actually addressing here. But generally speaking, if you're talking C-band, if you're talking 3 gigahertz in Europe or 4 gigahertz in Europe, it has to be compatible with the onboard system. So we would do that, at least in our development. We would be looking at all the interference environments on board the aircraft to make sure the system is compatible. David, do you want to add from the past experience, if anything here?
No, I'm focusing really on the network side of this, so it'll be, let's say, secondhand knowledge from my side. So quite happily defer to you.
Yeah.
And the next question is also maybe Jim, if you want to comment on this. It says, how are you addressing the potential frequency issues with radio altimeters?
I don't know that I've heard of radio altimeter concerns, but certainly there have been discussions about GPS. And last year, there was a lot of conversations with the FCC regarding some things Legato was doing and how they were deploying a network, which is actually L-band. And so it wasn't 5G. It wasn't the technology that was of concern with GPS. It was the L-band antenna being tuned to 5G frequencies and its proximity to GPS, and that it could create some interference issues. I know there was a lot of conversation between the coalition of parties in the opposed to what Legato was trying to do. But in terms of GoGo 5G, we don't expect any interference issues with any onboard equipment.
And we only really have time for about one more question, so I will leave it off with this one and throw it open to the panel. We've already talked about the hardware and some of the devices. This question comes from Etihad Airways. What will be the key impact on flight operations, especially data transmissions, in terms of cost and transmission uplink or downlink? So pretty open-ended question there. Any of our panelists want to just start and weigh in on that?
I could start briefly, or Jim, do you want to take a punt at it?
I'll go after you.
So there's a lot of data. So let's talk of the EHM use case around engine health monitoring use case as a typical use case. For example, that that generates a lot of data on board the aircraft. Traditionally, either AirCast is used to transmit this data or the satellite connectivity is used to transmit this data. Obviously, I'm taking a particular use case here just to simplify the discussion. And AirCast, while it's very reliable and safety approved, it's not the most cost-effective way to actually do it. So what 5G, or generally what air-to-ground brings, is effectively a really low cost per bit model, effectively providing a pipe that you could envision, which is a flat rate pipe, or you can consume just like you have on your phones with some fair policy, and encouraging operators to effectively use that pipe to transmit more data and optimize their operations, which is quite expensive with the models that exist at this point of time. So one thing 5G could improve, but also 4G would do the same job, is effectively opening that pipe up and providing the capability to airlines to use that pipe effectively to improve their operations. As an example, engine health monitoring is one of the use cases. So I'll stop here and maybe Jim.
Absolutely. Bigger pipe, cost-effective relative to SATCOM. If you think of the infrastructure investment of a satellite network versus an underground network, it's order of magnitude, more expensive there. The other thing that Gogo's done on this for our business aviation customers is that we have basically a Wi-Fi hotspots that we provide to our customers to access the Gogo cloud. And so when aircraft come in to hangars or even within a few hundred feet of a hangar, we provide a free free pipe to offload and offload data off the aircraft, push data to the aircraft through these Wi-Fi units free of charge. Right? So if you're on the ground near a hangar, you can do all of this data transmission for free. If you're in the air, then exactly as Aman said, air to ground is a very cost-efficient mechanism to do that.
Can I add to this for a second?
Sure.
I think traditionally, this kind of data uses L-band, right? The ACARS system and so on. But over the last few years, I've seen a lot of interest with product providers and even airlines, whether they could use a broadband network or a secured portion of a broadband connectivity for this, which if you look at from that perspective is significantly going to bring the cost down, right? Because L-band has a much higher cost to run than a KU or a KA network. So one of the things we recommend is for technology to break down that pipe, which is really a satellite pipe from the aircraft to the ground and vis-a-vis, into two different virtual channels, if you will, one secured and one for the passenger, and use that secured channel going to perhaps a different endpoint and actually use flight operations that way, right? Data that way to reduce cost. Now, that is not to say that while the aircraft has landed, to Jim's point, the entire 5G or the Wi-Fi network or a localized Wi-Fi doesn't take over. So that's the advantage of an integrated network. But there are ways to reduce cost on the air, right? For commercial aircraft, which are flying globally, and use a secure channel over a broadband network.
Okay.
That's all.
Okay. Well, that brings us to the end of the panel. As everyone can see from the number of questions, I think this is a very, engaging topic and one that the industry is very focused on and, excited to see become a reality in the near future. So I want to thank all of our panelists here, Jim, David, Aditya, Amar. Thank you for joining me this morning for this panel on 5G. I want to thank our sponsors, Intelsat, SES, and Comtech Zycom for helping us put on this panel. We will have another panel starting at 10:30 a.m. if you are interested on the cost of making in-flight connectivity free. And thanks again for tuning in this morning.
Thank you.
Thanks a lot, Woodrow.
Thanks for having us.
Thank you very
guys.
much. Thanks for having us.
Thank you.
Cheers.